Welcome back to the Deep Dive.
Okay.
This time we're tackling Clean Architecture by Robert C. Martin, the
Yet.
book you've been wanting to explore.
Oh, yeah, this one's been on my list for a while.
Got excerpts ready to go.
Awesome.
I'm already buzzing.
Okay.
Good architecture is like the foundation of a well-built house, right?
That's a great analogy.
Yeah.
Yeah, and just like a shaky foundation can cause all sorts of problems down the line.
Oh, for sure.
Poor software architecture can lead to a system that's difficult to maintain,
Right.
impossible to scale,
Uh-huh.
and a nightmare to debug.
So are we talking about those moments when you add a new feature and 5 other things break?
Exactly.
Yeah.
That's often a symptom of poor architecture.
I've definitely been there.
Robert C. Martin calls it the signature of a mess.
Okay.
Essentially, the cost of each new feature becomes exponentially higher
Oh, yeah.
as the code base becomes more tangled and complex.
Okay, so how do we avoid creating that mess?
Right.
The excerpts mention structured programming. Is that where we start?
Yeah, it might seem that way.
Feels kind of old school, doesn't it?
It might seem that way.
Yeah.
But the principles behind structured programming are incredibly relevant,
Right.
even in today's world of fancy frameworks and agile methodologies.
Right.
Think of it this way. Structured programming,
Okay.
with its emphasis on clear control flow, using sequence selection and iteration,
Yeah.
paved the way for what we now call functional programming.
Okay.
And that's all about creating code that's easier to reason about,
Okay.
test, and maintain.
Ah, so it's like the grandparent of the clean code movement.
Exactly.
Okay.
It all started with folks like Edsger Dijkstra
Sorry.
trying to bring some order and predictability
Yeah.
to the world of programming.
That makes sense.
Remember his famous letter, go-to statement considered harmful?
Oh, yeah, I've heard of that one.
He knew that uncontrolled jumps in code execution were a recipe for spaghetti code
Oh, yeah.
and unmaintainable systems.
So structured programming laid the groundwork,
Yeah.
but then object-oriented programming came along,
Yeah.
right? Did that solve all the problems?
Well, not quite.
Okay.
Robert C. Martin points out that while object-oriented programming brought some fantastic tools to the table,
Okay.
like encapsulation,
Mhm,
inheritance,
Yeah.
and polymorphism,
Okay.
it wasn't a magic bullet.
Okay.
In fact, he argues that some of the core concepts of OO
Okay.
were already present in earlier paradigms like structured programming.
So it's more of an evolution than a revolution.
That's a great way to put it.
Okay.
Take encapsulation, for example.
Okay.
C programmers were already using structures and functions to
Ah.
bundle data and behavior together
Yeah.
long before OO languages came along.
Right.
OO just formalized and popularized these concepts.
Okay, that makes sense.
Right.
But what about those truly unique aspects of OO, like polymorphism? How does that fit into this whole clean architecture picture?
Polymorphism is where things get really interesting.
Right.
It allows us to write code that's incredibly flexible and adaptable.
Okay.
The book uses a simple example of a copy program to illustrate this. Imagine you have a program that copies data from one input device to an output device.
Okay, like copying files from a hard drive to a USB stick.
Exactly.
Okay.
Now, with polymorphism, you can easily add new input and output devices,
Okay.
say a scanner or
Yeah.
a network connection,
Right.
without having to modify the core logic of the copy program itself.
Gotcha.
This is because you're working with abstract interfaces, not concrete implementations.
So the core logic doesn't care where the data is coming from or going to.
Right.
It just knows how to handle the data itself.
Precisely.
Okay.
And that's a key principle of clean architecture,
Right.
decoupling those core business rules from the messy details of how data is input, output, or stored.
This is starting to make a lot of sense.
Good.
But you know, they say with great power comes great responsibility, right?
Oh, yeah, absolutely.
If we're not careful, this flexibility could lead to more complex code.
Yeah,
That's even harder to manage.
you're absolutely right.
Yeah.
And that's where the solid principles come into play. They act as a set of guidelines, almost like a checklist,
Right.
to make sure we're using the power of O in a way that leads to clean and maintainable code.
Okay, so let's dive into these solid principles.
Okay.
But can we make this practical?
Yeah,
I learn best with real-world examples.
absolutely.
Okay.
Let's start with the single responsibility principle,
Okay.
or SRP.
SRP.
Think of it this way.
Okay.
Each module or class in your code should have one and only one reason to change.
Okay.
If you find a class doing too many things,
Yeah.
that's a red flag.
Like if I had a class that handled both user authentication and sending email notifications, that would be violating SRP.
Exactly.
Okay.
It's like having a chef who's also responsible for washing dishes and taking out the trash.
Right.
They might be able to do all those things,
Yeah.
but they're probably not going to be very good at any of them.
For sure.
And it's the same with code.
Right.
Keep your classes focused on a single responsibility,
Okay.
and your system will be much easier to understand and maintain.
Okay, so that's SRP.
Right.
What about the O in solid?
That's the open-close principle, or OCP.
OCP.
It sounds a bit paradoxical,
Yeah.
but it essentially means designing modules that are open for extension but closed for modification.
So I can add new functionality without messing with the existing code.
Right.
How does that work in practice?
Think of it like building a house with a modular design.
Okay.
You can add new rooms or features without having to tear down existing walls.
Okay.
In code, this often involves using abstract interfaces and polymorphism.
Okay.
You define a contract through an interface and then create different concrete implementations that fulfill that contract.
Okay, so if I wanted to add a new payment method to my e-commerce application, I wouldn't modify the existing payment processing code directly.
Right.
Instead, I'd create a new class that implements the payment processing interface.
Exactly.
And just plug it in.
Exactly.
Yeah.
The existing code remains untouched.
Okay.
Minimizing the risk of introducing bugs or breaking existing functionality.
That makes sense.
And it makes the system much more flexible and adaptable.
That's a great example.
Thanks.
So we've covered SRP and OCP.
Right.
What about the next one, the L?
That's the Liskov Substitution principle,
Okay.
or LSP.
LSP.
It's all about ensuring that when you use inheritance, you're doing it in a way that maintains the integrity of your code.
Okay.
Think of it like those square and rectangle examples you mentioned earlier.
Yeah.
If a subclass can't truly substitute for its base class without causing problems, then you're violating LSP.
I'm starting to see how these principles work together. Each one builds upon the previous ones, creating a more robust and maintainable code base.
Right.
Okay, so what about the I?
That's the interface segregation principle, or ISP.
ISP.
It's all about making sure your interfaces are tailored to the specific needs of your clients.
Okay.
Instead of having large monolithic interfaces that force clients to depend on methods they don't actually use.
Yeah.
You break your interfaces down into smaller, more focused ones.
So instead of having a giant God interface that does everything, you have several smaller interfaces, each responsible for a specific set of functionalities.
Exactly.
Okay.
It's like going to a buffet and only taking the food you actually want to eat instead of being forced to load up your plate with everything.
I like that analogy.
Good.
That makes a lot of sense.
Yeah.
So last but not least, we had the D in solid.
Oh, okay.
What does that stand for?
That's the Dependency Inversion principle, or DIP.
DIP, yeah.
It's one of the core principles that enables loose coupling and makes our systems easier to test and change.
Okay, but how do we actually invert dependencies?
Yeah.
It sounds a bit like magic.
Think of it this way. Instead of having high-level modules depend directly on low-level modules, you introduce an abstraction, typically an interface, that both modules depend on. This allows you to swap out different implementations of the low-level module without affecting the high-level module.
So if I have a module that handles user authentication and another module that sends email notifications, instead of having the authentication module directly depend on the email notification module, I'd create an interface for sending notifications.
Exactly.
And both modules would depend on that interface.
Exactly. That way you can easily switch out different email providers or even choose to send notifications through a different channel altogether without having to modify the authentication module itself.
Wow, these solid principles are really starting to click for me. It's not just about following rules. It's about understanding the underlying principles and using them to guide your design decisions. It's about thinking about the long-term maintainability and flexibility of your code.
You got it.
Okay.
And remember, applying these principles effectively takes practice and experience.
Oh, yeah, for sure.
It's about developing a clean code sense, an intuition for what makes code well-structured and maintainable.
So these solid principles, they're like the building blocks for creating a clean architecture.
Yeah, exactly.
But how do they actually fit into the bigger picture? How do they translate into a concrete architecture?
That's where the clean architecture itself comes in. It's a way of structuring your system that takes all these principles and puts them into practice. And that's what we'll explore in the next part of our deep dive.
I'm ready for it. This is already changing the way I think about software design.
Good.
It's not just about making things work.
That's right.
It's about creating systems that are elegant, robust, and adaptable.
Absolutely.
I like it.
Yeah.
All right, I'm eager to unpack this clean architecture thing.
Okay.
It sounds like the holy grail of software design, adaptable, robust, maintainable, like a dream come true.
It's certainly a powerful approach.
Okay.
And it all revolves around a core idea.
Okay.
Separating the essential business logic of your application from the messy details of things like databases, user interfaces, and external frameworks.
Okay.
Think of it like a well-organized company.
Okay.
You have the CEO at the top making the big decisions about the company's direction, but they don't get involved in the day-to-day tasks of answering phones or filing paperwork.
Okay, so the CEO represents the core business logic, the brains of the operation.
Exactly.
Okay.
And just like a CEO has various departments handling different aspects of the business, the clean architecture has distinct layers, each with its own specific responsibility.
So what are these layers and how do they fit together?
At the very heart of the clean architecture, we have the entities. These represent the core business rules and data structures of your application. They are completely independent of any specific technology or framework. Think of them as the fundamental building blocks, the unchanging truths of your domain.
So if we were building a social media app, an entity might be something like a user or post. Precisely. Things that exist regardless of whether we're using a relational database or a SQL database.
Precisely.
Okay.
Now, surrounding those entities, we have the use cases.
Use cases, okay.
These represent the actions that users can take within the application. They orchestrate the flow of data to and from the entities and implement the application's behavior in response to those user actions.
So for our social media app, a use case might be something like create a new post or send a friend request.
Exactly.
Actions that users can perform within the app.
Exactly.
Okay.
And the use cases are still pretty high level, focused on the what of the application, not the how.
Okay.
They don't care about how the data is displayed on the screen or stored in a database. They just define the logic of how the application responds to user requests.
Okay, I'm starting to see how this separation of concerns works.
Yeah.
But what about those messy details we talked about earlier? The databases, the user interfaces, the frameworks. Where do they fit in?
That's where those outer layers come in. We have interface adapters, which act as a bridge between the use cases and the outside world.
Interface adapters, okay.
They handle things like converting data to and from the formats used by the database, the user interface, or external systems. Think of them as translators. Ensuring smooth communication between the different parts of the system.
So if our social media app uses a relational database to store user data, an interface adapter would handle converting the user entity into rows and columns in a database table.
Exactly.
Okay.
And on the other side, it would handle converting those rows and columns back into a user entity when the application needs to work with that data. And finally, in the outermost layer, we have the frameworks and drivers.
Frameworks and drivers.
These are the concrete implementations of things like the database, web framework, the UI toolkit. They are the tools that we use to build the system. But they should never dictate the structure or logic of the core application.
Okay. This is all making a lot more sense now.
Good.
So the clean architecture is like an onion.
Yeah.
With layers of increasing detail as you move outwards.
Exactly.
But how do we ensure that this separation of concerns is actually enforced? How do we prevent those messy details from creeping back into the core business logic?
That's where the dependency rule comes in. It's one of the most fundamental principles of the clean architecture. It states that dependencies should only point inwards towards the higher level policies. The entities and use cases being at the heart of the architecture should have no dependencies on any outer layers.
So the core logic doesn't even know that a database or a web framework exists?
Precisely.
Wow.
And this is what gives the clean architecture its remarkable flexibility and adaptability. You can swap out different databases, user interfaces, or even entire frameworks without affecting the core business logic.
That's pretty incredible.
Yeah, it's pretty powerful.
But I have to admit, I'm a bit skeptical. Doesn't this level of abstraction make the code more complex?
It's a good question.
And what about performance? Won't all this indirection and translation add overhead?
Those are valid concerns.
Yeah.
And it's true that a clean architecture might initially seem more complex than a more naive approach. But in the long run, it actually simplifies things.
Okay.
By making the system much easier to understand, test, and modify.
Right, I see what you mean.
Yeah.
If the core logic is well-defined and independent of those messy details,
Right.
it becomes much easier to reason about.
Yeah.
And to make changes without unintended consequences.
Exactly. And as for performance, well, it's true that abstraction can sometimes add overhead.
Right.
It's usually negligible compared to the benefits you gain in terms of maintainability and adaptability.
Right.
And you can always optimize specific parts of the system if performance becomes a bottleneck.
Okay, so far so good.
All right.
But how does all this translate into actual code?
Right.
How do we actually put these principles into practice?
That's where things get really interesting.
Okay.
The book provides lots of practical guidance on how to structure your code, how to manage dependencies, and how to design your classes and interfaces in a way that aligns with the clean architecture.
Can you give us a taste of what that looks like? Maybe a concrete example to help us visualize how all these pieces fit together.
Absolutely. Let's go back to our social media app example.
Okay.
Imagine you have a use case called create a new post.
Okay.
This use case needs to interact with several entities, like user post and follower.
Okay.
It also needs to enforce certain business rules, like ensuring that the user is logged in and has permission to create a post.
Okay, I'm following so far.
Okay.
So how would we structure the code for this use case?
You would create a class.
Okay.
Let's call it create new post use case.
Create new post use case.
That encapsulates the logic of this use case. This class would have dependencies on the relevant entities, like user, post, and follower.
Okay.
But it wouldn't have any dependencies on things like the database or the user interface.
So it would interact with the entities directly.
Right.
But it wouldn't know how the data is actually stored or displayed.
Exactly.
Okay.
And this is where the interface adapters come in.
Yeah.
You would create separate interface adapters for the database and the user interface.
Okay.
The database adapter would handle converting the entities to and from the format used by the database, while the user interface adapter would handle displaying the data to the user and receiving input.
So the use case would call methods on these adapters,
Yes.
passing in the entities or receiving data back,
Right.
without knowing the details of how the data is actually handled.
Precisely.
Yeah.
And this is what keeps the core logic of the use case clean and independent of those messy details.
Okay.
And then in your main component, you would wire all these pieces together.
Okay.
You would create instances of the use case, the adapters, and the concrete implementations of the database and the user interface. You would then inject the adapters into the use case. Okay.
So that it can interact with the outside world without knowing the specific implementations.
So the main component acts like the conductor of an orchestra.
That's a great analogy.
Bring all the different instruments together to create a harmonious symphony of code.
That's a great analogy. And just like a conductor doesn't need to know how to play every instrument, the main component doesn't need to know the details of how each individual component works.
Right.
It just needs to ensure that they're all connected and working together in a coordinated way.
This is starting to make a lot of sense.
Good.
It's about creating a system where each component has a clear responsibility, where dependencies are managed effectively, and where the core business logic is protected from the volatility of the outside world.
You got it.
Okay.
And by adhering to these principles, you create a system that's much easier to understand, test, and maintain.
Oh, okay.
And ultimately, that's what the clean architecture is all about, creating systems that are robust.
Right. Adaptable and a joy to work with.
So we've talked about the layers of the clean architecture, the dependency rule, and how to structure your code.
Right.
But there's another key concept that I want to explore. The idea of humble objects.
Okay.
What are they and why are they important?
Humble objects are a brilliant technique for dealing with complex logic.
Okay.
That involves those messy details we keep talking about, user interfaces, databases, external frameworks. They essentially help us create a clear boundary between the logic that's easy to test and the logic that's inherently difficult to test.
Okay, could you give us an example?
Let's say you're building a feature in our social media app that generates a personalized newsfeed for each user.
Okay.
This involves complex algorithms that analyze the user's connections, interests, and recent activity.
So this is the core logic.
Exactly.
The brains of the newsfeed feature, right?
Exactly. Okay. And ideally, we want to test this logic thoroughly to make sure it's working correctly.
Right.
But testing it directly can be tricky because it might involve interacting with the database to retrieve user data, making network calls to external APIs, or even manipulating UI elements.
So those messy details can make it difficult to write clean and concise tests for the core logic.
That's right. And that's where humble objects come in.
Okay.
We extract all the complex logic that involves those messy details into separate humble objects.
Okay.
These objects have a simple responsibility to interact with the database, the network, or the UI in a specific way.
So they act as intermediaries, shielding the core logic from those messy details.
Exactly. And because these humble objects have such a simple and well-defined responsibility, they're very easy to test.
Okay.
We can write unit tests that verify their behavior in isolation without having to deal with the complexities of the database, the network, or the UI.
And because the core logic is now decoupled from those messy details, it becomes much easier to test as well, right?
Precisely.
We can write tests that focus solely on the logic of generating the newsfeed without having to worry about those external dependencies.
Precisely.
Okay.
The humble object pattern allows us to achieve that separation of concerns, making our code much more testable and maintainable. It's like having those soundproof booths in a recording studio. You can isolate the individual instruments, record them cleanly, and then mix them together later to create the final track.
That's a great analogy.
Thanks.
So the humble objects handle those noisy, hard-to-test parts. And the core logic can focus on its job without distractions.
You got it.
Okay.
And this leads to a much cleaner and more robust system overall.
Okay, so I've covered a lot of ground here. The layers of the clean architecture, the dependency rule.
Humble objects. And the importance of testability. This is all starting to feel like a powerful toolkit for building amazing software.
It certainly is.
Okay.
And remember, it's not just about applying these concepts blindly. It's about understanding the principles behind them and using them to guide your design decisions. It's about making conscious choices that lead to a system that's well-structured, maintainable, and adaptable.
This is all incredibly insightful, but I'm also realizing that building a clean architecture requires a shift in mindset.
Yeah, I think that's true.
It's not just about writing code that works. It's about thinking about the long-term health and maintainability of the system. It's about embracing those upfront design decisions and resisting the urge to cut corners. Or to prioritize expediency over quality.
You're absolutely right. It's a commitment to excellence.
A dedication to creating software that's not just functional, but also elegant, robust, and a joy to work with.
And it's about remembering that we're not just building systems for machines to execute. We're building systems for other humans to read, understand, and maintain.
That's a crucial point. And it's something we'll explore further in the final part of our deep dive, where we'll delve into the human side of software architecture and how to create systems that are not only technically sound, but also a pleasure to work with.
Welcome back to the final part of our deep dive into Robert C. Martin's clean architecture. We've already uncovered so much. The importance of solid principles, the power of the clean architecture's layered approach, and the elegance of humble objects.
Those were really interesting.
Now, in this last part, let's explore how those principles translate into real-world decisions. Especially when it comes to choosing technologies and frameworks.
Because
we've discussed those can be both powerful tools and potential pitfalls.
Because I'm starting to see how a clean architecture mindset can really change the way we approach those decisions. It's less about chasing the latest shiny framework. And more about making thoughtful choices that align with our long-term goals.
Exactly. Remember how Robert C. Martin argues that frameworks are details? Powerful tools, but ultimately replaceable. If our architecture is screamingly clear, the specific framework we use becomes less critical.
That makes sense.
But
let's be honest. Sometimes those frameworks can feel pretty tempting. They promise to solve all our problems. Make us super productive. And maybe even brew us a perfect cup of coffee in the morning.
I hear you.
And
it's easy to get caught up in the hype. But the clean architecture encourages us to be discerning, to weigh the benefits against the potential costs.
because the cost of tight coupling to a specific framework can be pretty high.
So it's like choosing a foundation for our house, right?
Yeah.
We want something solid and adaptable,
right?
Not something trendy that might crack under pressure a few years down the line.
That's a great analogy.
Yeah.
We need to ask ourselves,
okay,
is this framework aligned with our long-term goals?
Yeah.
Is it mature and well-supported? Does it impose constraints that might hinder us later on?
And honestly, sometimes the best framework might be the one we build ourselves.
Yeah.
I'm thinking back to that kitty problem you mentioned earlier, where a seemingly simple feature ended up tangling several microservices.
Yeah.
Maybe a more cohesive, custom-built solution would have avoided that mess.
That's a great point. Right. And creating what's truly best for our system.
And this whole idea of deferring decisions, it plays a huge role here, right?
Absolutely.
If we can avoid locking ourselves into specific technologies too early, we have more flexibility to adapt as our understanding of the problem evolves.
Absolutely.
Okay.
Robert C. Martin talks about the importance of creating a plugin architecture where components like the database, the UI, or external integrations can be plugged in and swapped out without disrupting the core logic.
So it's like having a universal power adapter.
Yeah.
No matter what kind of device you plug in, it just works.
Yeah.
Because the underlying system is designed to handle those variations.
Exactly. And it's not just about technology choices.
Okay.
This principle of deferring decisions applies to design decisions as well.
Right.
We want to avoid those G&I traps.
Yeah.
Those moments where we over-engineer a solution for a problem that might never actually arise.
I can definitely relate to that.
Yeah, me too.
It's so tempting to build in all these bells and whistles.
Right.
Just in case we need them later.
Yeah, just in case.
But often, those extra features just add complexity and clutter.
Yeah.
Making the code harder to understand and maintain.
That's why simplicity is such a core value in the clean architecture. It's about creating systems that are elegant, clear, and focused on solving the essential problems.
I like it.
And this ties into another key concept that Robert C. Martin emphasizes, the importance of clean code.
Right.
He's not just talking about formatting or style, but about writing code that's expressive, readable, and easy to understand.
It's like the difference between a messy workshop and a well-organized one.
Yeah.
When everything has its place, it's easier to find what you need, and you're less likely to trip over something or break a tool.
That's a great analogy. And just like a well-organized workshop makes it easier to build things, clean code makes it easier to build and maintain software.
Right.
And it's not just about making the code easier for machines to execute.
Right.
It's about making it easier for other humans to understand.
Yeah, for sure.
Because software development is a team sport, and we have a responsibility to each other to write code that's clear, concise, and well-documented.
And this brings us to a point that's really resonating with me.
Okay.
The idea of software development as a craft.
Yeah.
Robert C. Martin talks about this towards the end of the book.
Right.
And it's a perspective that elevates our work beyond just writing code.
It's about approaching software development with a sense of pride and ownership.
Okay.
Striving to create systems that are not only functional, but also beautiful, elegant, and a pleasure to work with.
I love that.
Yeah.
It's like the difference between a mass-produced piece of furniture and a handcrafted piece.
Yeah.
Handcrafted piece has soul. It has attention to detail.
Right.
And it reflects the passion and skill of the artisan who created it.
And that's what we should strive for in our software as well. To create systems that are not only robust and adaptable, but also a reflection of our best efforts, our commitment to excellence, and our respect for the craft.
So as we wrap up this deep dive into clean architecture, I'm left with a sense of both excitement and a touch of healthy anxiety.
Yeah.
It's exciting to have this new perspective, this toolkit for building better software. But it's also a bit daunting to realize how much there is to learn and how much we need to unlearn.
I feel that too.
Okay.
It's a journey, not a destination.
Right.
And the clean architecture is not a rigid set of rules, but a set of principles that can guide us as we strive to create software that stands the test of time.
So for our listeners out there, the challenge is this. Take these principles. Experiment with them. Apply them to your own work.
Right.
Find what resonates with you.
Yeah.
What helps you build better software.
And remember, it's not about perfection.
Okay.
It's about continuous learning,
right,
continuous improvement, and a commitment to the craft of software development.
Thank you for joining us on this deep dive.
All right. Thanks for having me.
It's been an incredible journey.
Yeah.
And I hope you've found it as insightful and thought-provoking as we have.
Me too.
Until next time.
Yeah.
Keep learning.
Keep learning.
Keep building.
Keep building.
And keep the code clean.
And keep the code clean.